Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try this question yourself, pause the video now. If you came up with an answer B, 0.47 amps, give yourself a pat on the back. If you want to see my explanation and how I found the answer, please continue watching. So, question. Two identical batteries, each with an EMF of 1.5 volts and an internal resistance of 1.6 ohms, are connected in parallel. A 2.4 ohm resistor is connected in parallel with this combination. Now, a lot of students get worried when they see EMF and internal resistance. I have a neat little trick that makes it a lot easier. Instead of drawing the cell correctly as a cell, we're going to draw it in the following way. We're going to just call this the part that produces the EMF, and then we're also going to produce an internal resistance for each cell, and then show the whole cell as this dotted line. And of course, that would be the same for the cell on the bottom here. Okay, so let's start putting things in that we know. We've got an EMF of 1.5 volts. So if I just look at this, 1.5 volts there. The other thing we know is we're given the equation EMF is equal to current multiplied by any external resistance plus the internal resistance of the cell. I can rearrange that to give the following. And because potential difference equals current multiplied by resistance, I can substitute V for IR, and we get EMF is equal to the potential difference plus the current multiplied by the internal resistance. Now, this value of V, this potential difference here, is what we call the terminal PD. It's actually the potential difference that we'll see on the ends of the battery, the actual potential difference that we get from the battery. And that'll be the same value here and across here, and the same value that's going to be across either side of the resistor. Through the resistor, there's going to be a current, and we'll call that current I, and that's actually what we're trying to find in this particular question. If the current is I through the 2.4 ohm resistor, because the current is going through each of these branches, each of these branches must have half that total current. So I can say through this branch, the current is I over 2. And obviously, whatever is true for this top branch is the same for the middle branch here, because the cells are identical EMF, identical internal resistances. So let's just rearrange this equation to give me that the terminal PD is going to equal the EMF minus the current times the internal resistance. And I can just put a couple of numbers in here as well. The EMF we're told is 1.5 volts. The current we don't know, but we do know it's going to be hung off the current we're looking for. So I'm going to put I over 2 for the current there. And the internal resistance we're told is 1.6 ohms. Just simplifying that, I can say that the terminal PD is equal to 1.5 minus 0.8 I. Now, I can come up with a nice simple value for the current, for the potential difference across this 2.4 ohm resistor. potential difference is the current multiplied by the resistance. Well, this potential difference is the terminal PD. It's the same as the PD we've got there. The current, we said we're going to give the value I, and the resistance is 2.4 ohms. So the potential difference, the terminal PD, is 2.4 I. Because these two PDs are the same, I can just say that 2.4 I is equal to 1.5 minus 0.8 I. Rearranging, I get 3.2 I is equal to 1.5, or I is equal to 1.5 over 3.2, which is 4. I do apologize, it's 0.47 amps. And if we expand out, answer B. I hope you found this useful. Please like and leave a comment below, and I hope you'll watch more in the series.